Welcome to today's lesson. We're beginning with indices. Now, for us to appreciate how to solve questions involving indices, we must look at the laws of indices. Laws of indices. Now, what we'll do is to analyze the laws one after the other. So let's start with law number one. Law one. Now, the law says that when you're multiplying two indices, all you need to do is to add their powers, m plus n. Now please note something, that the a is the base, while the m is the power for the first one. It's multiplying the base a and the power is n. Now before you can add the powers of indices, you must ensure that the base are the same. So this is a and this is a. And because the two bases are the same, then it's possible for you to add the powers to get a value of what you're looking for. Now, let's look at some examples under this law. Let's assume the question asks me to simplify the following. Number one, I have m raised to the power 3 times m raised to the power 4. The base are the same, m. So it's possible for you to add the powers, 3 plus 4. And the answer to this question is m raised to the power 7. Now let's try at another example. Number 2. Let's assume I have 3 n raised to the power 2 times 6n raised to the power 5. Now in this question, the part we're concerned about is the base. The n are the same. So first, the coefficient, you had to multiply them separately. 3 times 6. And then times n raised to the power 2, because you're multiplying, plus 5. This will give you 3 times 6, that's 18. And then n, 2 plus 5, it's 7. Let's look at number 3. If I have 4 a raised to the power 2 b raised to the power 5 times 5 a raised to the power 4 b raised to the power 6. Now again, we're going to follow the same procedure. In this case, we're going to multiply the coefficient separately. 4 times 5. Then a raised to the power 2 plus 4. Then b raised to the power 5 plus 6. And this will give you 4 times 5, 20a, 2 plus 4, it's 6. Then b, 5 plus 6, 11. That is the answer to the question. So we could see that this is very easy. Now let's go to law number 2. Law number 2 is called the division of indices. So here I have a raised to the power m divide a raised to the power n. Now, if I have a question like this is the same thing as saying a raised to the power m divide a raised to the power n. So here, when you're dealing with division in indices, the division means subtraction minus n. As long as the base are the same, all you need to do is to subtract the powers. Now let's look at some examples as we apply this law. Now let this be number 4 example. In this example, I'm simplifying y raised to power 9 divide y raised to power 3. Now because it's division, I'll simply subtract the powers. 9 minus 3, y raised to power 6. Okay, let's try another one, number 5. 25 d raised to power 8 divide 5 d raised to power 6. This is 25 divide 5. You divide the coefficient separately. And then, since the base are the same, d raised to power 8 minus 6. 25 divide 5, it's 5. D, 8 minus 6 is 2. That is the answer to the question. Now let's try out number 6. Number 6 question, I have 9, open bracket, a raised to power 6 divide a raised to power 3, close bracket. Now, this 9 is outside the bracket, so it has no business with whatever happened inside the bracket. The base is a, so you pick one of the a. 6, because you're dividing, subtract, or minus 3. And the answer to this question is 9a raised to power 3. So this is easy. Now let's go to law number 3. Law number 3 is a raised to power m, close, in bracket, then raised to power n. In bracket in mathematics means multiplication. So if I have a raised to power m, bracket, that means multiplying raised to power n. This will be a raised to power m times n, which gives you a m n. That's simply the law. So let's apply it. Now remember, we'll stop at number 6. So let this be number 7 example. If I have m raised to power 4 in brackets raised to power 5, this is simply m raised to power 4 times 5, which gives you m raised to power 20. Let's try another example, number 8. If I have 8y raised to power 4 all raised to power 2. Now, in this case, you have to be very careful with the indices. Everything in the bracket is raised to power 2. That's the meaning. So each of these terms are raised to the power of 2. It means 8 is raised to power 2 and y raised to power 4 times 2. 8 raised to power 2 simply means 8 times 8. 8 times 8. Then times y raised to power 4 times 2, 8. So the answer to this question becomes 8 times 8, 64, y raised to power 8. That should not be a problem. Now let's try number 9. Minus 6 n raised to power minus 3, all raised to power 2. Now again, you have to be very careful with this. Everything in the bracket again is raised to power 2. So what do I do? It means I'm going to consider each of the terms. Minus 6 in bracket raised to power 2, and then n raised to power minus 3 times 2. Remember, bracket means times. So this will give you minus 6 raised to power 2 is minus 6 times minus 6. And then times n raised to power minus 3 times 2 minus 6. And this is minus times minus, it's plus. 6 times 6, 36. And then you have n raised to power minus 6. That is the answer to the question. Let's move to law number 4. Law number 4 is called the power of zero. Power of zero. Now this is the zero. It means anything raised to power 0 is equals to 1. So if I have 2 raised to power 0, it's equals to 1. If I have 3 raised to power 0, it's equals to 1. If I have n raised to power 0, equals to 1. So the point is, anything you raise into the power 0, it's 1. Well, let's see how we could apply the rule as we continue our example, the number 10. I'm to simplify 7x raised to power 0. Now, what is the answer to this question? Here, 7x raised to power 0 means 7 times x raised to power 0. This is multiplication. So this is like saying 7 times 1. This one is coming from x raised to power 0. Since x raised to power 0 is equals to 1, it becomes 7 times 1. And your answer is simply 7. This is no problem. Let's try another one. 3y raised to power 0 divide 3 raised to power 2. In this case, you have to be very careful. This is 3 times y raised to power 0 is 1. Divide. I can use the division sign now. 3 raised to power 2. This division sign and this division sign are the same thing. So this becomes 3 times 1, 3. 3 raised to power 2 means 3 times 3. Now I can here just cancel out the 3. There's a common factor here. 3 can divide the numerator 3, and 3 can also divide the denominator 3. So here it's 1, 1. So the final answer to this question is 1 over 1 times 3, 3. I guess this should not be a problem. Now let's try out number 12. Let's assume I have a question where I have 4y raised to power 0 times 3y raised to power 2. Now, this is also very easy. Multiply the coefficients separately. 4 times 3. Now, because the base here are the same, y, you apply the multiplication law. 0. Multiplication means plus 2. And this gives you 4 times 3, 12. Y raised to power 0 plus 2, 2. That's all. But if you want to use an alternative method, it's also possible. Because under this law number 4, we talk about the power of 0, that anything raised to power 0 is 1. If I decide to do that, alternative solution, this is what I'm going to get. Alternative solution. If I have 4y raised to power 0 times 3y raised to power 2, this is the same thing as 4 times 1, because the y raised to power 0, it's 1, times 3y raised to power 2. 4 times 1, 4, times 3, that's 12. And then y raised to power 2. You see, you're getting the same answer. So the beauty about math is this. You are not stereotyped that you must follow a particular method of solving a question. I always tell my students, solve math the way you understand another way another person understand it. That way, maths become easier. Now we're moving to law number 5. The law number 5 is called negative indices. This is a raised to the power minus m. This minus is called inverse. I can take it away from this term or these indices. All I need to do is say 1 over. So with this, the inverse is gone. A raised to the power m. Now we're going to apply this as we continue example. Let this be number 13. Now in this case, I'm simplifying 4 raised to the power minus 3. This is simply 1 over 4 raised to the power 3, which is 1 over 4 raised to the power 3 is 4 times 4 times 4 3 times. And this is 1 over 4 times 4, 16 times 4, and that's 64. So 1 over 64 is the answer to the question. Let's try out number 14. I have 10y all in bracket raised to the power minus 2. If I have a question like this, what do? I take away the inverse. How do I take away this minus sign? To take away this minus sign, rather, I'll say 1 over, that's the inverse. Then 10y all raised to the power 2. This will give you 1 over, you see, each of these 10 will be raised to the power of 2, which is 10 raised to the power 2, y raised to the power 2. This will give you 1 over 10 times 10, y times y. That's the meaning, which is 10 times 10, 100, y raised to the power 2. Well, there's no point expanding the y raised to the power 2 anyway, but I just wanted to understand the concept of y raised to the power 2 simply means y times y. Okay, let this be the last example for this law. Now let's assume I have 9 open brackets 2y close bracket raised to the power minus 2. Now what does this mean? In this case, this 9 is outside the brackets. So it's not affected by this power minus you have here, the minus sign. It's not affected by, it's not affecting 9, but rather it's affecting what you have only inside the brackets. So this is my 9. And then every other one times 1 over, that's the inverse, 2y all raised to the power 2. So the inverse is not affecting the 9. So this is 9 over 2 raised to the power 2. That's the meaning of this. And then y raised to the power 2. And this will be 9 over 2 times 2. That's the meaning of 2 raised to the power 2. That's 4y raised to the power 2. That is the solution to the question. Now this brings us to law number 6. Law number 6 is called fractional indices. Fractional indices. If I have x raised to power a divide b, this is a fraction, a over b. What does this mean? See, the denominator here is b. Let me write this well so that you understand what I am writing, over b. So it's a fraction. The denominator is b and the numerator is a. When you have a work like this, the denominator tells you the root sign x, while the numerator tells you the power. So let's see another example. Now this will be example 16. If I have 27 raised to the power 2 over 3, this is cube roots. The denominator is 3, so it's going to be cube roots. Raised to power, the numerator is 2 raised to power 2. And this will give you the cube root of 27 simply means what number would you multiply 3 times? That's meaning of this cube root. 3 times 3 times 3 is the number you multiply to give you 27. 3 times 3 is 9. 9 times 3 is 27. So to take away the cube root sign, you pick just one of the three, then raise to power 2. And that gives you 3 times 3, 9. That is the answer to the question. Now, let's try another example. Let this be number 17. If I have 16 raised to power 1 over 2, this is square root 16. The denominator is 2, so it's square root. I don't need to write 2 here. This already tells us that it is a square root, then raised to power 1. But there's no point doing this. I just want you to understand the concept of the numerator here. Square root 16 means number you multiply 2 times, since it is square, 2. And that's 4 times 4. All raised to power 1. But there's no point because anything raised to power 1 is that thing. So you pick one of the 4, and that is the answer to your question. And let's check at number 18. If I have 16 raised to power 3 over 4, this will be the fourth root, since it's the denominator, then raised to power the numerator, which is 3. This is the same thing as, what number would you multiply 4 times to get 16? 2 times 2 times 2 times 2. Or raised to power 3. So you pick one of the two, then raised to power 3. And this is 2 raised to power 3 means 2 times 2 times 2, 3 times. 2 times 2 times 2, it's 8. So this is the answer to the question. Let's try out number 19. Here I have 16 over 81, all raised to power 3 over 4. Against the same thing, the fourth root of 16 over 81, all raised to power 3. Now, it means the number you multiply 4 times to get 16. And that number is 2 times 2 times 2 times 2, 4 times. Then the number you multiply 4 times to get 81, 3 times 3 times 3 times 3, 4 times, all raised to power 3. So this gives you, pick one of them, 2 over 3 raised to power 3. So this is 2 times 2 times 2, 3 times, 8. 3 times 3 times 3, 3 times, and that's 27. That is the answer to the question. So we can see that this is not difficult at all. Now let's look at further examples in indices. We have to simplify the following terms. Here, the number 1, I have 6x raised to the power 7 divide 3x raised to the power 3. Now this is very easy. I'm going to divide the coefficients separately. And since the base are the same, xx, I'll pick one of the base, raised to the power 7. Division means minus in indices, remember? Minus 3. So this will cancel this to be left with 2. And then x, 7 minus 3, x raised to the power 4. Let's try number 2. Number 2, I have 4y times 3y raised to the power 4 divide 2y raised to the power 3. This is 2. Now, if I have a question like this, what do I do? Again, I'm going to multiply the coefficients separately and divide by the denominator separately. and then since all the base are the same, y, or pick one of the y. Now, the power here is 1, but we don't usually write it in math. So it is y raised to the power 1. Multiplication is addition plus 4. This is division. Division is minus 3. Now, before I multiply, I'd like to divide to make it easier for me. 2 here, 1. 2 here, 2. Remember, I said softmax the way you understand. Then 2 times 3. I'll be left with 2 times 3. Then y, 1 plus 4, 5, minus 3. And this will eventually give us 2 times 3, 6, y, 5 minus 3 is 2. That is the answer to the question. Now let's try out another example. Let this be number 3. Now let's assume I have 15 m raised to the power 3 n raised to the power minus 2 divide 3 m raised to the power minus 2 and then n raised to the power 2. They are all in brackets and they are all raised to the power minus 1. Now this is a little bit complex. If I have a work like this, what do I do? Well, I'll show you a very easy way of taking away this minus sign. Remember, the minus sign here is inverse, which is usually 1 over. But here, what you have in a bracket is a fraction. You have the numerator part and the denominator part. So instead of doing 1 over this, there's no point in that. If I have an inverse like this and what I have in the bracket is a fraction, simply put the denominator, take it to the numerator, and take the numerator to the denominator. So I'm going to exchange what I have here. This denominator will become the numerator becomes the denominator. So here I'm going to have 3m minus 2n raised to the power 2 divide 15m raised to the power 3 n raised to the power minus 2 or raised to the power 1. So the inverse is gone. Now, because it is raised to the power 1, it doesn't really matter if you put it or not. But just in case you have 2 here, then you know here is going to be 2. But since it is 1, here will be 1. At this point, it's easier to simplify now, right? So the 3 will cancel, and the 3 will cancel 15 to the 5. So here you have m, so the base are the same here, and the n and the base are the same. So you're going to have, pick one of the m, minus 2. Division, it's minus. What you have here is 3. Then n raised to the power 2. Division, it's minus 2. Open a bracket for the minus 2. Over 5. So don't forget, the 5 is still at the denominator. So this will be m minus 2 minus 3 is minus 5. In simplifying terms like this, I've done a previous video that can help you and call it foundation mathematics, things you need to know that can help you in simplification. You can check out my previous video on this. Then n raised to the power 2 minus times minus is plus 2 over 5. And this will give you see, this is an inverse. This m raised to the power minus 5 is an inverse. So which means to take away the minus sign, just take it to the denominator. That's it. So here I have n, 2 plus 2, 4, 5, m raised to the power 5. I guess that should not be a problem. Anytime you have the inverse, it means take it to the denominator. But if it's a fraction like the question, exchange both terms. Take the denominator to the numerator and take the numerator to the denominator. That's all. And so this is the answer to the question. Now let's go to number 4. Here I have 7a all raised to power minus 1 times 7a raised to power minus 1. Now, how do I solve this question? Now, please check out this question. You notice that in the first 7a, the 7a is in the brackets. So every term you have here in the bracket is raised to power minus 1. But it's quite different from the second term. Here, only the a is raised to power minus 1. So you have to be very careful when you have work like this. This is the same as 1 over 7a. You see, that has taken away the inverse, all raised to power 1. But you don't need to do that, but we had to. Times 7, only the a will go to the denominator. That's it. I hope that's clear now. This is 1 times 7, 7. And this is 7, a times a. Because this a raised to power 1 is a raised to power 1 here is a. Now at this point, the 7 can cancel the 7. And so the final answer becomes 1 over a squared. That's it. But let's try number 5. This would be the last example. I guess all of these should have guided you or aid you in solving questions that has to do with simplification of indices. Okay, this is another question. A raised to power minus 1, b raised to power 5, or divide a raised to power minus 6, and then b raised to power minus 4. See, the bases are the same, minus 1. Division is minus, then minus 6. Then you pick the b raised to power 5. Division is minus, minus 4. Open a bracket for minus 4. So this is a raised to power minus 1. Minus times minus is plus 6. And this is b raised to power 5. Minus times minus is plus 4. And this will give you minus 1 plus 6. This is 6 minus 1. That's a raised to power 5. And then b a raised to power 9. That is the answer to this question. So these questions are easy to solve. Okay, you have some exercises to do for me. You have to simplify number 1, 5y raised to power 6 times 8y raised to power minus 11. Number 2, 9y are in brackets or raised to power minus 1. And then times 9y raised to power minus 1. And number 3, 39a raised to power 4, b raised to power 3, divide 13a raised to power 6, b raised to power 0. Please do this. Put your answers in the comment section. And see you in the next video. The next video will talk about solving equations with indices.